Welcome guys to the first video of this incredible channel, Ninja Combo. And real quick, my name is Salman Adnan and I am currently studying in college in 12th grade. And in this channel for the first 6 months, we are going to discuss and make videos on computer science O levels and A levels combined. So today, so let's start the video. So today our topic for today is binary system. So real quick, I'm really going to start with the base power of 10. I really hope that you all are familiar with base power of 10, 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4 and so on. Just as this 10 power 0 stands for 1, 10 power 1 stands for 10, 10 power 2 stands for 100, then 1000 and then 10,000. Similarly, in computer science, instead of using this base of 2, this base of 10, we use the base of 2. Now, why we use this? This concept will be clear later on in the video and later on in the lessons. And just like as we start here from 0, from the index number 0, we will also start here from the index number of 0. And that's the basic rule of computer science, that in many cases in programming in binary system, our basic rule is that we start from the index number of 0. So up here 2 power 0 stands for 1, of course, 2 power 1 stands for 2, 2 power 2 stands for 4, 2 power 3 stands for 8, 2 power 4 16, 2 power 5 32, 2 power 6 64. So that's really the basic concept which we are going to build later on in this video. So the next we are going to focus on is how is this thing represented in computer science in terms of computer science language, in computers, registers and processors. We are going to discuss it right now. This is discussed in two types of state. Number 1, on, and number 2, off. So of course we cannot write this on and off in processors and microprocessors and all of those devices and stuff. So instead of writing on and off, we represent on as state of 1 and off as a state of 0. So right now let me take a quick example of 8 numbers consisting of zeros and 1 combination, and let me tell you how it's done. Let's say 0010. Wait a second. Let me make boxes to make it even more clear. So 8 boxes. Now the reason why I choose these 8 boxes is because in computer science we have like fixed number of bits that we choose one after another, and this is the concept that I will discuss later on in the lessons. I'm not going to discuss it right now, so you can just say I'm going to consider an 8-bit number right now. Okay, so let's say this is our number. So in this case, this representation is gonna come in handy to get the output of this result. How it's going to work? It's going to work like this. We are going to place 2's, just a second. We are going to place 2's on the top of every box. And instead of starting from here, we start from here, because in computer science, in binary system, we go from left to right whenever we read a number. Whenever we read this representation, we go from right to left, not from like left to right in normal maths. So again, since we go from right to left, it means the number will get from small to big. So here 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, 7. That's all of these powers, and if you translate these powers, these will become 1, 2, 4, 8, 16, 32, 64, and 128. Now, how we are going to process this to get our result? Now, before I tell you how to get the result, let me tell you that this representation of zeros and ones is called binary. Zeros and ones is called binary, and all the real numbers, which means all the whole numbers or all the decimal numbers like 4.2, 5.6, 5.88, all of these numbers we consider them as denary, which means that we are going to convert this result into denary, this binary number into denary number. Now here's how we're going to do. All those states that are 1, it means that all those bits, all those states are on, and the corresponding number with those bits will be considered in calculating. So for this instance, we will use this number, we will use this one, since it's 1, it's an on state, this one bit is an on state, and all those states which are 1 will be added to get our final result. And hence it will become 64 for this one and 4 for this one. We will add both of them to make our final result 68. So these both bits are added, the 64 with this one, 4 with this one, and these both are added to get our final result, which is 68. Let's consider another example. Let's say we have another 8-bit number. 1, 2. Let's now say we have 000 11101. So again we are going to start from the index of from the base power of 2 and index of 0 to power 0, to power 1, to power 2, to power 3, to power 4, to power 5, to power 5, to power 6, and then to power 7. And after translating these numbers, we get 2 power 0 is actually 1. Here you go, 1, 2 power 2, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4, 16, 2 power 5, 32, 64, and 2 power 7 is 128. Now the basic rule that we applied here, that all those bits, all those states that are 1 will be considered, and all those states and all the corresponding numbers with those 1 state or with those on state will be added to get our final result, which is denary. Now we are going to convert this binary into a denary. So this state is on, this state is on, this state is on, and this state is on. Now let's add all of these numbers to get our final result. 16 plus 8, 24, 24, 28, and then 29. And this is a denary number. This is a denary number. Thank you very much guys for watching this video. Make sure to like, subscribe, comment and share this video so more and more people can benefit from this video. I will see you in the next one.